Hello everyone. In this video we will complete our examination of topic D.3 cosmology, and in particular we will complete examining the accelerating universe and redshift. So the previous graph, the graph examined in the previous video, is the single greatest piece of evidence for the fact that the expansion of the universe has over time accelerated. However, that's not a very satisfying thing without an explanation. So, why is the universe accelerating? Why is the expansion of the universe accelerating? There is a very simple answer to that, which is dark energy. Dark energy is the thing that is expanding the universe, or sort of promoting the expansion of the universe and creating the acceleration of that expansion. A reminder, it is not a surprise that the universe is expanding. That's what we expect given the Big Bang. That was initially known in the 20s from Edwin Hubble. It is a great surprise that the expansion of the universe is accelerating. And what is dark energy? It is the name we give for the thing that is causing the accelerated expansion. So if this seems circular to you, it is. And in fact, it is a great coup that what we call dark energy gets funding in exploration from things like the U.S. Department of Energy. In part because dark energy is simply what we are calling whatever is causing the accelerated expansion. There is a reason for that name, but big picture, we don't know what it is. We don't have a great theory. There are a number of possible theories for what is causing this. But saying that it is caused by dark energy is a little bit like simply naming the problem. Let's take a look at a couple of these charts. Examine two charts here, Universe 1 and Universe 2. Universe 1 has slow expansion. This graph right here is sort of an inverted Hubble graph. It's showing how the recessional velocity is related to the distance. So slow expansion, you will see galaxies moving not as far away at the same distance. If they are at a particular distance in a rapidly expanding galaxy, then they will be moving faster. So Universe 2 has rapid expansion. Universe 1 has slow expansion. Notice that this is the same set of axes, this distance and recessional velocity, fundamentally, as the Hubble graph. It's just inverted. And so what this means, we can use these two slopes. So a higher slope on this graph means slow expansion. A lower slope means rapid expansion, which means that a universe that has expanded more slowly in the past, so the expansion has sped up, is going to be sort of moving to that higher slope over time. Okay, so this universe has expanded more slowly in the past, and the expansion has sped up. That's what is actually happening. Whereas a universe that expanded more rapidly in the past, so that expansion has slowed down, corresponds to sort of this curvature here. And this is what we would expect. This is what is actually happening. A graph that corresponds to a universe that expands at a constant rate would be a straight line. So when we compare the sort of this graph to the supernova graph, we can say that, all right, with higher redshift z here, that means that you're getting more significant recessional velocity. So the recessional velocity is related to the redshift. And with higher distance, that would mean the supernova appear dimmer. And so this graph is effectively what is being interpreted from these supernova. And we are seeing that slight curve is within our error bars. So very, very comfortably, confidently in the accelerating frame. And this corresponds to a flat universe with dark energy. And we're going to explain what that means in a further video, optional, that brings in some HL material. So dark energy is possibly what is known as vacuum energy, which is a negative energy density hypothesized by quantum considerations, basically when particles pop in and out of existence in the process of pair production. You might expect there to be this kind of a thing that is sort of exerting an outward pressure proportional to the volume of space. Notice that if that's the case, then the bigger the universe is, the higher that outward pressure is, and so you get an accelerated expansion. Unfortunately, vacuum energy, as calculated with quantum mechanics and quantum field theory, gives a value for the dark energy that is quite literally 10 to the 130th power off. So it is not close. So if it is vacuum energy, something else is going on. Although there are some additional theories. To explain more about the nature of dark energy will require some HL plus material and some further cosmology, and that will be examined a little bit later on. Big picture for SL, dark energy is the answer to the question, what is causing the acceleration of the expansion of the universe? But big picture, we don't know what dark energy is, so that is perhaps not a great explanation yet.